Hi Math 30s. This video is going to be the first lesson in our last chapter, and the last chapter is on something called permutations and combinations. The first lesson is on something called the fundamental counting principle, and I will do this first lesson in at least 2 videos. One thing I just want to note is that I use my own note package for permutations and combinations. So a lot of the examples are from the workbook, but I've combined it with diploma questions and things like that. So you'll want to make sure you have the note package printed off. On the Google Classroom, you'll see a blank copy of the note package as well as this note package filled in, and then you'll be able to go through the videos to get the answers. Okay, on this first page, I want you to highlight this word combinatorics, and basically what that is, it's the art of counting. So with permutations and combinations, a lot of the questions in this unit are going to involve how many of something. So we're just dealing with the art of counting in this unit. What I also like to tell students is for those of you that create study guides, this is the vocab that would be in all of permutations and combinations. So the first lesson is going to take care of the fundamental counting principle, and then this would be the remaining vocab. So I always say, like, these terms here you just need to know very well, and examples of all of these terms for this unit. Okay, what we're going to start with is something called the fundamental counting principle. So I'm going to show you how we could do a question the long way, and then what the shorthand would be using this fundamental counting principle. So what it says is, suppose you go on a trip and you pack 2 shirts and 1 pair of pants. How many different outfits could you make? So what you would say is you would say, okay, I'm going to pack with this pair of pants the number of outfits that I could have. I could join it with this shirt for 1 outfit, or I could join it with this shirt for 2 total outfits. So the answer would be 2 outfits, right? If you have 2 shirts and 1 pair of pants, you've got 2 total outfits. In the second example, it says, now suppose you pack 3 shirts and 2 pairs of pants. How many different outfits could you make? So going back to, let's start with this pair of pants. That pair of pants could make a total of 3 outfits because I could join it with any of those 3 shirts. And then I would say this pair of pants, I could make 3 outfits from. So if I had 3 shirts and 2 pairs of pants, the total number of outfits that I would have would be 6 outfits. What's going to happen is that questions that I'll give you using the fundamental counting principle are going to be way more involved, where we're not going to actually figure it out by hand, and we're going to use what's called the fundamental counting principle. What the fundamental counting principle does is it says, consider this as a task made up of different stages. So what it would be, it would be the number of shirts would be your first stage, right? And the number of pants would be the second stage. And then what you would do is you would say, okay, how many choices do you have for the first stage? So for the number of shirts, I have 2 total choices. For the number of pants, I have 1 total choice. And what the fundamental counting principle says is, once you figure out how many choices you have in each stage, you simply multiply those numbers together to get your answer. So 2 times 1 would be 2 total outfits. If I was using the fundamental counting principle for this example, so stage 1, again, is the number of shirts. However, in this stage, I have 3 total choices. So I've got 3 shirts that I could choose from. Pants would be my second stage, and I've got 2 pants to choose from. 3 times 2 would give me 6 total outfits. So that is summed up right here, okay? So the fundamental counting principle says, consider a task made up of several stages, and then we'd figure out the number of choices for the first stage, the number of choices for the second stage, the number of choices for the third stage, and then the number of ways that a task can be completed. So I'm going to highlight that actually in a different color. So the number of ways that a task can be completed is by multiplying the choices in each stage, and that's what we call the fundamental counting principle. So I'm going to give you now a more complicated example. So what this says, if we look at this, it says, for example, a restaurant meal consists of one of two salad options. So the first stage is salad, right? And there's two salad options, so maybe like Caesar salad and garden salad. So in that first stage, there's two possible choices. Then you get a choice of 3 entrees. So the second stage would be entrees. And we have 3 entrees to choose from. So let's say like a fish, a steak, and a pasta entree. And then after that, we have 4 desserts. So the third stage would be desserts. And there are 4 desserts to choose from. So if you go to a restaurant and they have 2 salad choices, 3 entree choices, and 4 dessert choices, the total possible meals that you could make would be 2 times 3 times 4, and that is equal to 24 possible meals. And that's using the fundamental counting principle to figure that out. Okay? So again, each stage, and then you figure out the number of choices in each stage, and you simply multiply those together, and that's how you apply the fundamental counting principle. This one is just saying, look at the choices again. So this was a shirts example, and it was saying set it up using the fundamental counting principle, which we already did. Right? So if I just go back here, this would be our answer using the FCP, which is the fundamental counting principle. Okay, so let's look at this. One thing I just should have a note up here. When they use in math the word and, what happens is and is going to be multiplying. So when they say and, that's going to be a big clue that we're multiplying. Okay, so let's do this. This was a diploma question, and it involved the fundamental counting principle. Josh wants to rent a car. He has narrowed his choices down to a sedan, a compact, or an economy car. So the first stage is the type of car that he wants. And he can choose between a sedan, a compact, or an economy. So for the type of car, there's 3 different types. Then within these 3 different cars that he can choose, he has to pick a color. And the colors available are black, red, or white. So that would be considered our second stage. And there are 3 colors. So the choices are black, red, or white. He may also choose, when you buy a car, you can choose if you're going to buy a standard or an automatic transmission. So the last thing he has to decide is his transmission. There's only standard or automatic to choose from, so there's 2 choices there. So the fundamental counting principle, the number of options that Josh has in buying a car is going to be 3 times 3, which is 9. 9 times 2 is 18 total options. And that's the answer. Because remember, he could get a sedan that's black and automatic, or he could get a sedan that's black and a standard, right? Then he could get a sedan that's red and automatic, a sedan that's red and standard, right? So all of those, if you did it by hand, you get 18 total options, and I would never recommend doing it by hand. Just use your fundamental counting principle. Okay, so here's where things are going to get a little bit more complex. From 2010, Alberta assigned license plates with 7 characters. Okay, so right now, any of you that get a new vehicle, you're going to get a license plate that has 3 letters followed by 3 numbers. Prior to 2010, what the license plate had were 6 characters. So it had 3 letters and 3 numbers. This is important for when we do like letters and numbers. In the alphabet, so A to Z, there's 26 letters. So I often tell students, like, put that on your study sheet. And then the digits that we have from 0 to 9, there are 10 digits. So in the alphabet, in our alphabet, there's 26 letters and there's 10 digits from 0 to 9. So the first question says, how many license plates were possible with the old plate? So if you look at the old plate had 6 possible stages, right? Because it went letter, 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 number, number, number. So draw yourself 6 different stages. And so this is for A. The letters go here, and the numbers go here. Okay, there's no restrictions. What no restrictions means, it means there could be repeats, right? So it means we could have A for like our first 3 letters if we wanted. So because I need letters to go here, there are 26 letters in the alphabet. So there's 26 choices there, 26 choices there, and 26 choices there. The numbers are from 0 to 9 that you could go here because we could have the number 0. So there's 10 digits here, 10 digits here, and 10 digits here. What we would do when we do the fundamental counting principle to find out the total number of license plate is we need to multiply this all together. How I'm going to type this on my calculator is instead of, I could do 26 times 26 times 26, or I could just do 26 to the power of 3 times, again, I could do 10 times 10 times 10, or 10 to the power of 3. So if you enter this into your calculator, what you will get, the total number of license plates before 2010 were 17,576,000 for the total number of license plates. 17,576,000. Then what they discovered is they discovered that they actually needed more options than this. So they decided after 2010 to add an extra stage, to put an extra number. So this will be for B. And for B, what we could have is we could have 3 letters, and then we could have 4 numbers. So again, fill in how many options are for each stage. So there's 26 letters, 26 letters, and 26 letters, 10 numbers, 10 numbers, 10 numbers, and 10 numbers. So this one on the calculator, I would do 26 to the power of 3. And now it's going to be times 10 to the power of 4, because I had 4 different stages now for numbers. So from here, I've just changed my answer to 175,760,000. So this is equal to 175,760,000 total license plates are available when you have 3 letters and 4 numbers. Okay? Let's look at this think further. So think further. In example 2, it says, since the letters I, O, and Q could be mistaken for the numbers 1 and 0, right? So like, sometimes you don't know if that's a 1 or an I. That could look like a 0 or an O. What they did is it says, suppose these letters were not used on the license plates. How many new license plates are possible when the letters I, O, and Q aren't used? So what you would have to do, so let's say we were doing the new license plates. Oh yeah, because it says right here, sorry, new license plates. So for our letters, letter, 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 number, 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 we normally have 26 letters in the alphabet, but what we're going to do is we're going to subtract these 3 letters. So we're not going to use the letter I, O, or Q, just in case they're mistaken for numbers. So that gives me 23 possible letters to choose from. So now my choices for my letters are 23, and there's 23 choices for that letter and 23 choices. Again, this is called no restrictions, and no restrictions means I could use the same letter more than once. So that's why I would say 23, 23, and 23. The next example, we're going to involve something, we're going to use restrictions, so this will change. And then they never said anything about the numbers, so I still have 10 digits to choose from there, 10 digits there, 10 here, and 10 here. So let's do 23 to the power of 3 times 10 to the power of 4. So 23 to the power of 3 times 10 to the power of 4. And that gives me 121,670,000. Okay. That is going to be the end of the first part for lesson 1. And then what I'm going to do is I'm going to make a second video right away, and it's going to be on the exact same thing that we've been doing, the fundamental counting principle, except now we're going to involve restrictions. So that will be the second part.